just have a few more concluding comments about the caffeine experiment. One question is, if you were asked, is weight of the subject a confounding variable in this experiment, why or why not? You should say no, because the subjects were randomly assigned to treatments. People of different weights were randomly assigned to both groups, so weight should be fairly equally distributed in both groups. Weight would only be a confounding variable if I put all the heavy people in one group, say the non-caffeine group, and all the light people in the other group, say the caffeine group. So then if there were any differences in pulse rates, I wouldn't know how much of the effect was due to the caffeine and how much was due to the differences in weights. Now there will be some variability in both groups based on weights, but that variability should equally affect both groups, and any difference in variability should be due to the caffeine only. It's also important that all subjects in both groups are blind so that the expectations are the same for the subjects in both groups. They're their own expectations. For example, if the caffeine group, if I had half the group drink caffeine and they knew they were drinking caffeine and the other not drink caffeine, the caffeine group might expect their pulse rates to go up, and that expectation might actually cause their pulse rates to go up. Now that might sound odd, but I actually read of an experiment where one group was given some leaves to rub on their arm and told they were poison ivy, but they really weren't poison ivy. The other group were given some leaves to rub on their arm that they were told was not poison ivy, but it really was. Interestingly enough, the group that was told they had poison ivy developed the rash, even though it wasn't poison ivy. And the group that was told the leaf was not poison ivy, most of them did not develop a rash, even though it really was. So there is a very strong psychological effect called the placebo effect, in which people who are experiencing a treatment in an experiment psychologically react to thinking they're getting a treatment, whether they are or not. So if everybody gets a cup of soft drink and nobody knows which one they're getting, then everybody has the same psychological placebo effect, and so hopefully that is also equalized among both groups. In addition, if the people who measure the responses are also blind to which group is which, so that their judgment is not biased by their knowledge of which group is which, it's also called double blind. In this case, we were measuring our own response variables, which are the pulse rates, and my students didn't know which group they were in, so they were double blind. They were in the experiment and they were measuring the results, and they didn't know which treatment was which. Now notice, even though that control groups and placebo, control groups and blinding are very powerful techniques, we don't have to use them all the time. Not all experiments have to have a control group. For example, an experiment involving testing a new drug, usually the people that are in the experiment are people who are already on a drug for the same condition, and you can't ethically take them off the drug entirely. So half the group would be randomly assigned to the new drug and half to the old, and you just compare the effects. Similarly, there's times when you can't use a placebo at all. It's impossible to fake a treatment. Like if you're comparing 4 paint brands, it wouldn't even make sense to have a placebo paint. And you wouldn't need a control group either, because you're not really trying to compare paint versus no paint. You're just trying to compare different types of paint to each other. So to summarize now, with randomization, replication, and control, each treatment group should be nearly identical, and the effects of other variables should be about the same in each group. So any change we notice should be attributed to one of two explanations. Either any change we saw was just random variation between groups, because the groups do have other variables that are going to cause some variability in the results, or the treatment really did affect the response variable. So how big of a difference we see tells us whether or not it's actually an evidence of the response variable affecting, or sorry, the explanatory variable causing a change in the response variable, or the variation just was caused by random chance. And that is a probability question that we're going to be exploring in a further activity.